Hey, this is 7.3. This is the notes for the last section of the entire course. So this is law of cosines. So if we have a non-right triangle and we're trying to find missing pieces, and law of sines won't work, you don't have the right pieces for law of sines, then that's when you use law of cosines. Now, you can use law of cosines with the pieces from law of sines, but to be honest, it's a little bit more difficult, a little bit longer formula. So if you can use law of sines, then I think that's the easier of the two. So you try to use that first. But if law of sines won't work, this is law of cosines. Now you'll notice on the notes page, I included one thing, the triangle side length restriction. If you remember back to geometry, it was actually called triangle sum theorem. In any triangle, the sum of the lengths of any two sides have to be greater than the length of the remaining side. The reason that that's important, and you'll see in just a minute, is if they've given you the lengths of the sides and this isn't true, then it doesn't make a triangle anyway. So, so that's just something to keep in mind, that the other two sides have to be greater than the third remaining side always. That's the triangle sum theorem, or triangle side length restriction. All right, so here's our law of sines. You'll notice that at the front of each one, there's a small letter representing a side. So there's side A, and here's B and C. And then whatever's in after the equal sign, BC goes in front of cosine, and the angle matches whatever's side is on the left-hand side. So that's how we determine which one we're going to use when we look at a problem. So let's look at example number 1 about how to use law of cosines. So a survey, hold on just a second, because my picture went down to a separate page. So let me see if I can, oh, I didn't mean to do that. Let's see if I can. Well, I don't know. I'll just have to go down to it. A survey wishes to find, actually, let's just do that. There we go. A surveyor wishes to find the distance between two inaccessible points, point A and B, on opposite sides of a lake. While standing at point C, she finds that B is 259 meters, A is 423 meters, and that angle ACB measures 132 degrees and 40 minutes. Find the distance C. All right, so we're looking for distance C, which means that's which one I'm going to use. I'm going to use C squared equals, because that's what I'm looking for. So this is the law of sines that I'm going to use. C squared equals A squared plus B squared minus 2AB, because these match this, cosine of C. All right, so now it's just plugging numbers into formulas and solving using algebra. And there's only a couple little things you have to watch out for. So let's see. A squared, so 423 squared plus B squared is 259 squared minus 2 times 423, 259, cosine of 132, 40. Now, I actually need the square root, and this is actually kind of a nice thing about your calculator. I need the square root of this because I don't need C squared, I need C. So pretend that's in the right place. Your calculator will actually do all of this at one time. So let me pull up the calculator so you can see. I'm just going to plug that whole big thing. I'm going to get a square root sign. So there's my radical, and I'm going to type all of that in at once. 423 squared plus 259 squared, because your calculator knows how to do order of operations. So it can do all this. Now, depending on which piece we're looking for, sometimes it can't do everything. But in this case, if you have it all written with the something squared on the other side of the equal sign, your calculator will do it, no problem. So before I finish this, let's make sure I'm in the right mode. I am. Okay, so let me go back to where I was. I hate to type all that in and then find out I'm in the wrong mode. So, okay, cosine of 132, 132 degrees. Remember, that is second apps will get you your symbols for your angles. 40 minutes. and hit enter. And I get 628.1, and this is meters. So my answer is 628.1 meters. And that's it.